So again, knowing before we get like into urban design projects specifically, to understand always what is being driven, what are the challenges and the changes that are coming. So we know that we're going. So it's called ADAS, which stands for Advanced Driver Assistance Systems. So that's a kind of acronym to know. So Advanced Driver Assistance Systems. And these are technologies that get developed to assist us in driving, to kind of try to be, their goal is to be more efficient, right? And to be more safe is a big part of the traction of this kind of ADAS. Like collision avoidance, lane changing, follow suit, not having drivers falling asleep, human error. So that's one kind of push of why there's been, so we know that in transportation there's a kind of move from fossil fuels, right, to non-fossil fuels, right? That's where electric cars, blah, 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 all these more public transport and other modes of transport. That's one part of the story. But another part of the story is also accounting for human error. And so one side that technology has been developing is a kind of shift from fossil fuels to non-fossil fuels, all the way as possible. And another shift is kind of to reduce the capacity of us humans to make human errors and to make things more safe. So that's where we start to get this automation. Machines know better. Well, that's the argument we're now going into, right? So, of course, in order to have this, the technology that was really essential, and is still, of course, being developed step by step, is called LIDAR, or LIDAR. So it stands for Light Detection and Ranging. So it's a kind of remote sensing method that uses light in the form of a kind of pulsed laser to measure distances and proximities to things. So from that, we start getting this LIDAR, is really absolutely essential. So getting this kind of remote sensing and kind of, we'll see different systems. So it's really essential when we get to the kind of highly automated. But also if we understand, and this is a kind of universally accepted leveling of where you talk about how, so from the automotive industry, but also cities of trying to say we'll be at level 2 automation by 2030, no? So this is something that actually is urban design. I think you can also, once you know this, you can work it into, say, by the year 2050 in Ho Chi Minh, we want to be in level 3. In Palestine, so I think you can work this into your project, and it comes with a whole series of assumptions of how far you go. And it's considered, well, this LiDAR, so the kind of reliance on this kind of technology, right, is really essential when we get to the kind of highly automated, and that's where we read, in the newspaper how, there's still lots of, it's not worked out completely, so where we still have tests of, all these billionaires doing their playing around, and there's still crashes and that, so it's still being developed. But the interesting thing, of course, is that the rate of the science is ever more accelerating, and also the cost of the science is decreasing, as it's getting more affordable. So, and that's part of the story. It's a kind of super simple diagrams, but we have to understand. So again, the big things in mobility, right, is the biggest one is the shift from fossil fuel to non-fossil fuel, alternatives, whether it's bike or other anything that's not driven by fossil. So electric, okay, of course, coming then with a whole other set of issues. Batteries, we know, are sourced from mines and Congo, and comes from all these other set of issues because it's not also resource free. It's a different way of creating. So, but part of the whole story is that also with all of these things, we know that the technology is getting smaller, it's getting cheaper. But also I know, so my dad's an old guy, he's very kind of a technology freak. So he very early on said, I'm going to because he's not anymore such a good driver. So my brother and I encourage him to get all this electronic stuff. But the end also is, he is now a super electronic car. Getting this fixed costs a fortune. And understanding it as like a normal guy, it also, so that's where the industry is also still trying to kind of be super high tech and be as advanced as possible, but also how to make it relatable and even fixable to like a normal guy, you know? So it's also part of, and we're at the cusp of this, you know? So we're at the moment, of course, where we know all of this is happening. And incidentally, reflecting back on the collapse of Western civilization book, well, amongst also all these trade wars and all this kind of stuff that has been stirred up, one of the big things in the news is that this whole kind of transport revolution is being led by China also, and that the world should be ready to be flooded with Chinese market because they found a way to make cheaply very good kind of different levels of both new forms of mobility that's affordable to the masses. You know? So it's not a kind of elitist Tesla, but it's also kind of more, well, in Europe now there's many variations, but still in China it's another level of kind of interestingly kind of democratic way of kind of allowing this technology to come to more people. So again, how does this stuff work? It becomes more and more sophisticated, becomes more and more precise over time. So it's all about having these sensors that are, again, these pulses, laser, that are not only telling you about another car, but also people. So of course, this is technology. You say, okay, great, we understand it. But what becomes super interesting, and that's what we'll see, is the way it can drive completely new ways of thinking of infrastructure, particularly road infrastructure and urban design. And there's a lot of experimentation. Coming with that, right, we also know that we start having more and more, say, urban furniture as a necessity. So also, well, cluttering up, you could say, the public realm. No, well, we have maybe not so much in Leuven, but like in Brussels, half of the sidewalk now you have to walk in the road because it's all these scooters and e-bikes and all this kind of public infrastructure. So it's still kind of figuring out how to manage all of that. The charging stations, so there's quite, well, it's a new world still that is an opportunity for design because this isn't the public realm. Also in terms of this, so it's a kind of funny image, it's an image from China, but the idea is that they have now these funny car eating machines, but that basically can, the idea is it's a double-decker now, so just like a double-decker bus or train, you can now have, so you can, for a kind of piece, you're going on a long piece of the highway, and you're going from here to there, that you can kind of come in this thing as this kind of massive thing that's much more efficient. All the cars are like packed in front to back, touching each other at 2 levels, and it's also, so the interesting thing I think of some of these technologies that are a little bit still kind of wacky and out there is that they're fundamentally, what are they doing? They're changing the amount of area we need for roads because they're becoming much more efficient, right? And then we don't need as many roads. We can use that space, transform the space that is now roads to something else, and we can do things. So also, this is again a simple thing, but we know this is more and more happening. Stupid, I didn't take a screenshot of it or something, but I was reading an article the last days, and I forget where it was, I couldn't find it, but it was about, I think it was either Switzerland or Sweden, somewhere in Europe, that's sort of the nest, I don't know which country, but where they, in the railroad tracks, actually, so between 2 rails, they're also putting solar panels, you know? So of course, when a train runs, it's for a few minutes, but otherwise these things are kind of wasted space. know that it leads to a whole other networked system that's changing the way we move, but also changing delivery and all of these things as becoming as this kind of connected mobility landscape. So what I think is really nice, you can download this, at least you used to be able to. I think I've put this on box for everybody. If I haven't, I will do it. Because it used to be free to download, now I think they told me to be free. But I downloaded it when it was still free. So it's a nice little handbook. And for me, it's quite interesting. So it was made by a woman named Jeanette Sadiq Khan. She's a New York, she was a kind of hardcore lawyer, and she somehow started working for him. Bloomberg was a progressive mayor. She worked for him, and she started this thing called NACTO, so it's national animal something. And what she did is they started to add, so it was a look from, so at this point they said, okay, a lot of this kind of policies that we have around the world, they come from top down now. But this was a kind of group of cities, so like people working in the city, mayors, and like city scale. So can the cities develop their own policies, but also network and learn from each other. So she kind of had this kind of really nice idea to put together a bunch of cities. So like you signed up as a city, you didn't sign up as a person, you didn't sign up as a government, but like the city came on board. And then they started, and this one is from 2017 now, so it's quite old. But at the time they started also having more North American with Mexico and Canada. But I know that they're expanded to become worldwide. And so this was the first state publication they made, so it was an online thing. And if you look at NACTO on the website now, they've got like 20 books now, so they have a book about bicycles, a book about that. But all about trying to understand this kind of massive possibilities, revolution, say, in mobility. And really for them it's kind of the arrival of the self-driving, how it's a kind of historic moment to reconceive what is a street, right? And as well, very much to work towards safety, because we still have a lot of troubles about safety on roads. And again, they understand that we have more, and this is again old now, but that we have all of these kind of, so on the one hand we've got the technology moving, right? We have this need to kind of go from fossil to something else. But then we also have, with this whole new sharing economy, that we also have like, why should I own I forget now the exact statistic, but they looked at the average car that different countries, individuals have, and how much of the time it's just sitting there. So you use a car and you run to the grocery store, and you go pick up your kids, and you go to your job, but most of the time it's parked, right? So the idea is by using a car to its efficiency, it's never parked. We can reduce the number of cars if we share them. So why should I own a car if we can own 5 cars together and coordinate? But of course, there's a great business in that, the kind of cool business model. And then, for instance, even in Leuven and in Belgium, there's quite a few of these companies. So you can rent a car for an hour, or you can rent it for the weekend. But different than rent a car, but really as a kind of, you're a member of the club, and you just do it to your phone, and you find out it's there, and you can pick it up. And it's a quite cool system that's growing very, very rapidly. So of course we know it goes with cars, but it's also growing with bikes. And again, before we see some of the NACTO's stories, they also remind us that it's really interesting to kind of somehow keep up on these possibilities, because even though you could say, I never drove a car in my life, I'm not a car driver, and I could care less about cars, but they argue that we should all care about cars, to know the technology, even as architects and urbanists, to know what is possible, because So in that sense, it's interesting because we can maybe think out of the box if we understand we can do this and do that. And so what they started to do in Nashville, this group that came together with kind of interested city people and policymakers at city level, but then also experts who don't really know about road transport infrastructure engineers and know the evolving technology and how it's going to be in place. But they're trying to kind of create a system to explain how this is a revolutionary moment that we should catch up on, take advantage of. So just very generically, if we start getting rid of private cars and moving much more to public transport, done in different countries in different ways, with different degrees of success, but that we have kind of the public transport itself can also become much more efficient if it has designated lanes, it doesn't share them with bicycles, then we of course can have more frequent stops, and maybe that's done with sharing cars, so we got rid of the private car completely. But then of course what it does is it completely changes our relationship to the curb. So for them the curb, is always you have a road and then you have a curb, which is some centimeters, and then the safe. The curb was a lot about safety, right? And making a drop, so you feel it and you see it. But their argument is also it completely changes the curb. Maybe we don't need curbs anymore. That's what we start seeing in a lot of cities. They start having curbless streets, so they start creating a continuous surface from streets to say building facades in some places. And it changes the notion of a public realm, So of course you still can have cars that go through for emergency, and even cars. So I know in the center of Ho Chi Minh, in this gigantic access to the town hall, it's curbless. So they've made it so you can walk from a building to a building across the monumental access, and there's no curbs. So cars still go, but you have a completely different spatial perception and possibility of use of space. So what we're seeing here is that they also talk about some super general principles. Yes. So they just have some very, very generic, you could say, and these are made to be generic, so that they're made to kind of start a discussion. So almost things that I usually am very much against, like pool walks. But here they're so abstract that there are more principles that you have to go and take it to, like your city, and your city is different. And so the principle is, they understand that it's culturally based, but it's also spatially different depending on the kind of city. So, but they just have some very, very easy principles. And then starting to talk about how these streets will lead to a really different dynamic, primarily of public mobility, semi-private mobility, but then massive amounts of new claimed space for non-motorized. That's half of it. So then what they show, before we get into kind of really details, that also these principles also work along that line, if you remember, going from 0 to 5 in terms of automation. So when you get to kind of, so what you can do in the city and say reprofiling a street can be one thing when you only have a little bit of automation or no automation, but then when it's partial and then when it's full, so you can get progressively more radical as the technology is also becoming, the technology is already there. It's just not yet, say, completely rolled out in a public way. So then what they do in this thing, and I will give it to you as a PDF, is they start going through a hierarchy of different scales, of different kinds of streets, and actually what you could potentially start doing. So trying to frame how we can specifically design, reprofile streets that we have, right? So this is the kind of hierarchy they create. So they go from to a kind of larger scale on the left to a kind of more neighborhood scale. And then they say, okay, there's some, of course, every city is different, and the culture of the street is different. But in general, we have certain kind of standards, actually, about turning radius and busyness for streets that's more or less universal. So they try to develop this story. And then what they do, and this is what I think is interesting to see, is they try to visualize the possibilities for urbanism at each of these 6. So 3 scales, let's say city scale, 3 scales at the neighborhood scale. And yeah, they always do it in these kind of axonometrics. And then they really highlight at that scale, so at the kind of more zoomed out scale, right? So here we're looking at this multi-way boulevard, right? And understanding the major thing that you can do there is you can, well, you have to have access lanes, you have to have green infrastructure, and kind of a central bus only lane. And then what they include in all of them is literally, again, diagrammatically, knowing that every culture of a city is different, but a kind of before and an after section. You know? So these are always existing, and then what's new is in color. So it's kind of reducing the amount of cars, creating more public space, but then that also allows you to create maybe not asymmetrical, but also asymmetric sidewalks, to have more trees on one side of the road. Maybe it's also south facing, at least in the northern hemisphere, where you maybe want more shade. So to kind of get rid of our stereotypical, usually when we draw, so as architects, but coming from road engineering, we draw sections of infrastructure, we basically draw them symmetrically. And so they also start showing diagrammatically, like, why do we have to do that if we're thinking about environmental things? So if we come to the, say, next scale, again, some of the major things you should have. So the ingredients of reprofiling these streets, maybe the ingredients maybe change a bit. So you should still have dedicated transport lanes, but then you can start creating kind of hubs. And then they talk about this flexible zone, which is, we know that you have like places that are maybe part-time parking for delivery, these kinds of things. So for me, also living in the center of Brussels, when my street, when I moved in only 10 years ago, it was complete cars. And then they put cobblestones, and then they put ugly lights. But now it's all cafes and there's no cars. So there's no cars allowed in the city, and you can only, they have rules where you can only come in delivery, because there's cafes, between like 8 in the morning or 7 in the morning and 11. Like, but 11 in the morning, you have to be out. Like, if a car is there, you're fined and exorbitantly. You know? So it kind of goes with one hand, the physical redesign, the profiling of the streets, and then the programming that takes over almost without demanding it, but people see that it becomes a nice place to sit in a cafe, so cafe comes. But then it comes with also strong policy of how to control this, that you actually can have car-free areas. So it's a kind of, but is it the design first of the policy? I think, we don't need to wait for the policy. If the policy is there, take it and use it and make it better. But if it's not there, also make a project that can influence the policy. So they're showing, I think, interesting ways. And again, they go through these different scales. So still at the kind of larger scale, understanding the kind of downtown street, but then coming into the scale of a neighborhood. And that's where also maybe we understand that streets, we used to always see streets as kind of the fastest way to get from A to B, and there's kind of lines and efficiency, blah, blah, blah. But if we're now starting to change an idea of also mobility and passage through space, But maybe also when we get to where you see here, the road is not straight. Maybe if we also start to conceive, redesign the space between buildings, one side and one side, and redesign all of that. And maybe here, the reason we need a straight road is because it's efficient. But if it's a neighborhood road, anyways, we want the cars to be slow. So maybe it doesn't. Maybe by actually making it a little bit, you actually reduce, instead of having what we call sweeping policemen, these speed bumps, you instead can actually design a road that forces you to slow down. So it's also, I think, simple things, but things were not often, they're very, very systematic, and showing really how it can be reduced. Of course, we know in any urban design project, we also always have to account for, as much as we maybe want to kind of pedestrian this and you always have to be able to get fire trucks and ambulance, and they need a certain roughness that they can drive on that is not going to cost somebody their life, and the ambulance needs to show up. So those kinds of things, I think, are still in standards that we have to look at. But other than that, kind of, we can be more interesting in rethinking the space between buildings, and so that's what they try to show how we can do. One part that comes up, of course, in this kind of maybe group scale, and the big argument that worked for so long against public transports was what we call first mile, last mile. So people say, okay, great, I live in Leuven, I need to go to Brussels to work, the train is perfect. Yeah, but I don't live at the train station, I live in some suburban something, and if I have to wait for the bus there, it comes once an hour and it's shut, so it's much better to go in my car. And then also when I arrive in Brussels, my office isn't at the train station either, so okay, maybe I can jump in the subway, but if I'm off the subway line and I don't like the bus or whatever. So that was always called the first mile, last mile problem. And that's where all of this, so step in then sharing bikes, sharing scooters or whatever you call them, that these also become a bridge that makes public transport much more viable, So you don't have to worry, because the big, good train connection is of course not really called. So that's where this kind of last mile connections, and then what becomes so interesting about that is if we think, okay, when you exit, if you go to the central station in Brussels, you exit, and all around you've got scooters here, you've got those bikes there, and another bike here, and now they're kind of a mess, and they're just, now they start painting a square in the sidewalk and say, park there. People don't listen, of course. But if you see it as a design potential to make it into something that's not just a kind of place to throw your bikes, then it starts to become kind of interesting. As I say, the other thing they emphasize a lot in this story, again diagrammatically, which to me is very interesting, is that this time management. So what I was talking about in Brussels, so in the city centre of Brussels, they have designated areas, no deliveries, no after 11. So only emergency vehicles can go in after 11 in the morning. But understanding this and using it to design with can be super interesting, right? So that's one thing that we can start understanding, and that's where kind of suggestions to policy, we kind of thinking that the rhythms of the day and keeping a city functioning and getting the rhythms, and it has it doesn't need to be 24-hour, So that's where you start seeing also now fantastic in Brussels, a lot of these delivery things that are big bicycles, even with refrigerated, kind of big things, like little cabins that they drag behind them or in front of them. So it's also, it's leading to a whole new way of bicycle innovation as well. And then, of course, the other thing they mentioned, where again is for urban design, I think is kind of fantastic thing to think about, is what is the meaning of this curve. So also, even when Uber or whatever first came along, when it first was rolled out, and picking you up here, they're everywhere now. And then like airports and things like that, they started making like pickup zones and drop-off zones, because to try to control, because it destroys the flow. So that's one thing of having like, where do we have this interaction of going from like high speeds, centralized, maybe public transport, to then having, so how can you design the curb and that intersection between the kind of mobility and the kind of slow staying, pedestrian, water management, like how can we design these curbs to be very specific to their location and to the culture of the place. So if we know that a certain culture has a vibrant, informal economy, instead of banning it, can you actually design it as a kind of system that works to include time-based thing, or so other places where you say it can happen, places where it can't, instead of just saying no to everywhere. So for me, it's a kind of it's a very basic set of diagrams, and as I say, it's almost 10 years old, but still, I think it's interesting, and I'll make sure you can get it. But in general, NACTO, if you're interested in mobility and transport, they have, as I say, a lot of books. And they also either make books now about, so for a while they started with like cycles, but now they do things about kind of water management along roads. So they try to be very, well, it's not theoretical, they try to be super pragmatic, because it's meant as kind of helping cities just actually do real stuff instead of talking big theories about it. But it's, so in that sense, it's a kind of quite nice books. So this is again just showing like how if we take this kind of different notions, and this is very simple, we could invent many more, about coding, programming, and the curve. So how do we start to put that? So again, to not do monofunctional zoning, but to also have these curves that are maybe mixing and creating hybrids, and also working on a time-based thing. So it all becomes part of a very interesting way to rethink street profiles. And again, knowing that a lot of times when we look at retrofitting the existing city, right, and we say we need more space for water, we need more space for trees, there is no space, look, we can't take anything, we don't want to take down this house, people live there, we need more density. This is the place to do it, no? If we can radically transform, and if you extend this in the American city, but also in the European and other cities everywhere in the world, parking lots, which come with all of this. So if we need less cars, and if all the cars we have are constantly moving, picking people up, dropping people off, when they die, they go to the car death cemetery, cycling by the Japanese, and then you don't need car parking. Can you imagine if you don't need car parking, how much great public space becomes? So I think it's super interesting. And then of course, all of this shared stuff. Some places it's literally fun. I remember the country that was actually quicker about all the shared bicycles was China. And I remember 15, 20 years ago, they would show these kind of bicycle cemeteries of China, that they were just kind of, people with, because they were really early to do it, and it wasn't completely coordinated of like drop-offs and this and that, and they had so many people abusing them, and there were a lot of, if you look at kind of shared bikes, China, you see these incredible images of all these dead, massive amounts of bikes, because they were so early in the system, they didn't yet have a kind of organized way. And it's starting more and more. I mean, I know in the city of Paris some years ago, they banned scooters because they were too, so these electronic, not electric, like not Tesla, but these kind of kickboard, I don't know what you call it. But they banned them in Paris because they weren't quite a bicycle, they weren't quite a motorbike, they weren't quite pedestrian, and yeah, people were also putting 2 or 3 people on them, and they would go very fast, and they go on the sidewalk, and so it became this, so they banned them, and now they're slowly trying to bring them back, simply because they're trying to manage them, so there's kind of an outpouring, all these companies come and kind of flood the markets, and then the city has to see, like, how can we manage, and that's where it's still happening. And I think for urban design, if we think about designing a public space, or even now, if we know all these kind of food delivery by bicycle, at least in Brussels, they have very particular hangouts, and they're not very nice, they're kind of shitty spaces. And if there could be trees and cooling and a place to charge your phone, I mean, it could lead to a whole other set of design problems, but that become a great opportunity to make a new kind of public space too. So I think in this sense, it's interesting to take this on. And there are groups that are looking really into this, of how to kind of completely, say, turn upside down our idea of what is mobility. So where we see in this case, taxi being able to, so it doesn't have to be asphalt and the curb, and then where it's kind of flows, well, you have to organize the flows to keep it safe, of course. And then there's here in projects in Germany where they're also trying to, they've had a kind of design research at the scale of cities, trying to reorganize the entire workings of their streetscapes, which is quite interesting. So they had, in the middle of the 2000s, 2015, they started what's called the National Platform Future of Mobility in Germany. So it was the state, which we know in Germany is always quite good. Paradoxically, they have the least investment in their public transport, so everybody, you think all German trains work, clockwork. They're some of the most delayed trains because they haven't invested heavily. Well, it depends, of course, on the weekends. But even Angela Merkel, she called transport the big problem child of cities. So, understanding it needs to be done. So I think it's interesting the way we tie, of course, it's very important to address global warming, this transition, but it's also not only the technological, it's also a huge. This is was in a project in Toronto, so looking at what they call sidewalk labs, and also a lot of this done, again, with these Billionaire Boys Club, the Google Smart City, trying to make one, but also one this kind of smart transport was part of the game. We were going to make heating, so in the smart city of Google, they wanted to make heating without fossil fuels, but this whole thing, also where the car and the mobility system has changed to kind of work together with a new kind of public space. So they created something called TCAT, which is the Toronto Centre for Active Transportation. So there's a lot of kind of national, in the case of Germany, city-based programs that are really trying to well, of course, we'll see Barcelona and Paris that are trying to overlap. We know also there's both old and new systems of water transport. Of course, water transport, interesting that it's not taking space in the roads, but of course still a lot of the water transport is fossil fuel, so if it can be also water transport that's not fossil fuel, that's also an innovation of work that's being done. This was in the city of Chicago, quite well known Chicago riverfront. So the riverfront used to be a kind of dirty, so the nice water space of Chicago was the lake, and the river was kind of industrial, stinky sewage. And there was a major proposal to rework on the river, and actually to also have transport that then creates new public space. Also, these kind of water stop stations became kind of hubs of new kinds of public space. And in Chicago was quite well done. We know also looking at cities in Southeast Asia, where Bangkok is more well known, where they still have a kind of water transport system, say not tourists, but a kind of working system for okay, now tourism is aggravating me for some locals taking over parts of it in a way that makes it not so nice, but it's for a long time been part of the system of working. As I say, there's innovations. This is a kind of student project actually at Stockholm. It's called KTH, it's the Royal Institute of Technology, and they're also working a lot on transport, trying to kind of look at how to incorporate public transport in a way that's not fossil fuel based. So that's of course an interesting system. Then if we start talking about the bike networks and bike systems, so of course one of the leading in Europe, one of the leading cities, countries is Copenhagen. They've been really radical in their bicycle stories from early on. The first time I left the US to study was in Copenhagen, and it was already in the 80s. And it was, I did everything by bicycle. I took a train because family lived out of the center. Took a train, and then it was all bicycle, and they were just swarmed by bicycles. I mean, and the bicycle had the right of way because there were many more bicycles than cars. So the kind of bicycles ruled the world. They ruled the pedestrians and they ruled the cars because there were so many. Problem is in Copenhagen there were so many bicycles, and then also different bicycle etiquette. Some people riding like granny, and some people were going really fast. That they started having actually rules, almost like on the German autobahn, if you're on the wrong lane, it's like on the corner to you. And the same if you're in the wrong lane in Copenhagen, you get a lot of angry. So they started developing these super highways, bicycle highways, they call them. So this was the first bicycle highway that we see on the left. It was opened in 2012, and the idea. They're extending, they have more than 600 kilometers by now of these bicycle highways. And so they're really like high-speed highways, so it's not the local road. So you go to the local road, and then you get on this thing, and it's only bicycles, so no people, like if people are not allowed to walk on the snow, it's just for the bike. And again, it's very much, if you're slow, you should be on the right side, and if you're fast, no, it's a very, and of course, it creates new kind of public spaces. It creates new, so like where these ramps, in this case in the area of the harbor, where they land on the ground, it creates a certain kind of public space connection. So to me, it's a really interesting thing to think about how this can become a generator of a new form of public space. Also, mobility, of course, you can't talk about big strides in mobility without talking about this super block model. So I suppose most of you know this by now, but if you don't, this is the model of Barcelona. So Barcelona, Cerda's extension city. So Cerda was the kind of person where we got urbanism from, by the way. Spanish urbanist. So he made an extension of the city as 300 by 300 meter blocks, basically. Oh, sorry, 100 by meter. And what this is it's taking, where you see it there, 400 meters. So that's the scale of the block. So it's 133. The blocks of Cerda. So the idea is, I suppose maybe you've been to Barcelona, you've got this incredible iron grid of blocks. Very famous is that they're all chamfered on the edges, so you kind of get an intersection that's not right angles, but it's kind of shaped very nice. So the idea of the super block, which was all car, like this way, that way, okay, they did have a system of one-way, two-way, but one-way. But the principle of super block is that you take out, so you create a super grid. So you take out the 9 square grid, and And so the black in this diagram on the right, the black is still car, and it's again a very, very much a one-way system. And the rest of the roads are still there, but they're pulled out of the system. So the only cars that can get in there is ambulance and fire truck, right? And delivery. Okay, it's again this kind of going back to MACDO. So it's the kind of so of course there's still as far as meters or stench or tissue, you still have to get into the cafe. Blah, blah, blah. So this was proposed, and at the time it was considered like outrageous, no? And the shop owners were, if you're a shop owner in the middle, say, oh, I can't, you're going to bankrupt me, we're going to sue the city because I need the people coming by car, and I'm going to lose my market share, blah, 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 blah. So it was kind of, it took a long time to get off the ground because it was, this business interest, ecology interest, blah, 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 blah. But they pushed through. So they made that as a principle. So a principle is a principle, I'll explain that. And then what's also interesting to see in this principle is it's slowing down traffic, right? So it's massive, it's going from kind of 50 km/h, for instance, to 10, so it's also making a slow city. So that principle was worked across at the scale of Barcelona, which is diagonal, and all the kind of hierarchies and the kind of nuances you have in the city fabric. And then again, this was a plan that was kind of sitting there, and then they decided to kind of go how to start, and where do you start? Do you start my neighborhood or your neighborhood? To some degree, I might like it if I've got a bunch of kids and all that, but if I'm a shop owner, I'm probably a bit pissed off if I'm not on the block. So it became a lot of negotiation, and they started in 2 pilots. And at first they started, in some place, like what we see here on the left, it's really where they went for it completely, right? And and it's a more wealthy neighborhood. And they convinced the people that also were inside the block, that they would gain a new clientele because there's no cars, there's the whole for hotels and cafes and chic shops, so literally but then in some of the more rough neighborhoods, there was also, if you still see the car as like the answer, and like car accessibility is like making it, and then you take that away. So there wasn't as much, say, buy-in from political politics and the population. So then also not as much money to start. So they started experiments in different places, also with like maybe not as chic and as kind of design as we see on the left, but also doing kind of temporary tests, So using paint, literally painting the ground, and using planters like on wheels and pots, So all stuff that could be like, let's test it. Let's just, you're not convinced, but give us 6 months and we see if not, we'll be able to do it. And so they started this kind of selective testing, and it started to finally gain ground. So with a lot of kind of, say, vision, and then getting left-right politics, yes we do, no we don't do, yes we do, no we don't, and then just literally testing in different ways, ones with more buy-in and more permanence, and others that are more kind of testing, and now it's starting to kind of exponentially grow. So it's I think also interesting as an experiment to see how it's not just, if you don't get this grand idea, and then just go out tomorrow and do it, I mean, we often think like that, but like starting sparks here or there, trying in different ways in the same city very differently because the population is different, So it's I think a very, very wonderful example. So then I just show a quick, quite a few images, but I will go through them quickly here. This is a very, I think, interesting project made by Iñaki Alde and Margarita Hover, where they worked for quite some years, as you see, on the tramway in Zaragoza. So transforming this kind of major street boulevard connecting very important landmarks and places of the city into, so transforming this kind of connector into a place of public space. So getting away from this kind of just traffic, turning it into a public space with public transport and kind of rethinking at many scales of how they could start to work on this. So it's it's this piece that we see, and as I say, it's a very important area historically that has over time gained, you could say, landmarks, but still very much as part of the modernism or pre-modernism, having car, like with a car, the road and the car are the kind of drivers of urbanization and the kind of definers of the spatial logic. So looking at this, car, a very heavy duty car, and then they try to completely break down. So of course still having cars, so you've got cars to the outside, they put the cars, so they've got wide sidewalks, wide-ish. And then cars, but a special lane for this kind of curbside stuff. And then an entire central area that was pulled out of being car-based to become a roundabout, to become a boulevard and sitting lane. And because it's a strong thing, you can create different atmospheres to attract different groups of people along the way. So kind of working also on the materiality. So where you still have roads, where you have public transport, and then where you have sidewalk, we're creating, and of course this is like I say generic section, and it changes as it goes a little bit in this. But what was so nice about it is it really had a massive, was really again a road that was all cars. So this kind of bringing in vegetation, so bringing in like all the stuff we didn't have, bringing in water retention, invasion, bringing in the vegetation, bringing in the public transport, and then, as I say, because it has a long trajectory, creating kind of little groups. So if you've got a kind of green block, but then creating little pockets of play and dog park and I don't know, guys to play chess or whatever. So creating a kind of continuity, but still some places along its route. So it became quite a different notion, and again, very long one that had different pieces along the way. What was very nice is they got a chance to design also the urban furniture, you know? So how do you make a bus stop? You know? So the bus stop or the tram stop, starts to also become a kind of beautiful object that is also a light thing, but also a kind of green roof. So playing with this stuff, you know? So really getting to the scale of kind of whole transect, you know, the mobility system to bring it down to the kind of lighting design and seating design, etc. So that's one. And then I will quickly also go through the energy story. So the energy story, well, of course, we know the biggest part of the energy story is we want to go from this to first and foremost away from the way we generate power to renewable. We know that also a lot of our energy in our systems are super centralized, right? Which makes them really vulnerable because something goes wrong in one, you're finished. No, it's what we saw in the Spanish and the Portuguese blackout, you know. But if you've got a decentralized system, okay, one goes out and one neighborhood is but so the idea is to move much more to decentralized to also reduce risk, but also to be much closer to, it's much less transmission, no, it's cheaper. It's much less. So that we start going to small scale instead of big scale. We start distributing, so it used to be like my house takes water, I take stuff from the grid, right? You serve me, the grid. But now maybe my house can have solar and I only use a little bit, so I can actually put energy back into the grid now. So this is the notion that now it's not a kind kind of energy system that's kind of we take, but also we produce potentially at the scale of an individual house, neighborhood. And then also, of course, we know that technology is getting better, that we have these smart meters. So the same way when we were talking about with session about travel now, how the water technology now can give like 3 drops to this plant and 2 to that one. We also know the smart meters can now, so even in your house, we have smart thermostats. You can set it to turn off at night when you're getting lower, and to turn on when you're waking up, so you can not freeze when you go into your shower or not. But when this starts happening at the scale up, at the scale of cities, it's an enormous savings, it's an enormous efficiency, and it means we can maybe reduce, and especially because one of the big criticism of energy is when we go from fossil fuels to other forms like hydro and solar, is that they're not constant, with gas. Fossil fuels, we know, like we turn it on, we turn it off, and it's there. But of course, the smarter and smarter technology, we can store the solar, and so it all becomes part of the story. So, as we know, different countries in different contexts are having different policies, again changing with the wind of politics. But for me, what's interesting to see here, also we're in Belgium, was also good. So if we understand how we're doing in terms of the EU, in terms of renewable, so unsurprisingly Scandinavia, so Sweden, Finland, Latvia, the Baltics, Denmark, Austria, very good, Estonia, Portugal, and Belgium is kind of still better than the Netherlands, maybe a bit or so, but they're not very good. So I think it's also interesting to understand. The EU has supposedly one policy that supposedly everybody signed on to, but then how it gets negotiated. It's again what we talked about earlier, these kind of negotiations, and then really measuring. And what's interesting is also in 2020, the green dot was the target. And then you saw some countries, they already so the EU level was 20, so Belgium was already saying we can't do 20%. Our target then, some years ago, was what, 14 or something like that? No, but some countries already did better than their projection, and Belgium did not. Again, you've seen similar kind of things. When we were looking at some of the IPCC reports, this is particularly about Europe, so we're looking at Europe and looking from the 80s and understanding these different kind of renewable energies, which ones are gaining more ground. And of course, the ones that we know about and hear about most are the 3, so the wind, the photovoltaic, and the solar heating and cooling. Whereas the other ones, so ocean energy, biofuels, geothermal, and hydroelectric. Hydroelectric is also quite well known. It's not too prevalent, but there's still a development. So how does that work? How does all of this story about energy and about again global warming work in urban design projects? So this is to me a quite interesting project. In Taiwan, in Taichung, and it was made by Philip Braun. Philip Braun is a guy who's really a techno freak. He's really interested in climate and how to deal with the consequences of global warming through technological stuff, and kind of understanding also natural processes of heating and cooling, and how to basically hack it to make new propositions. Catherine Mosbach, who is a French landscape architect, a really wonderful person, really nice, really good designer. She teaches, she's lectured here quite a few times. She's a really fantastic lady. So these two kind of very different characters. They collaborated. Not easy collaboration. Well, I've heard from both of them. But anyways, they worked and they won a project, and it's being built in China, in Taiwan. Sorry. And this was done with the cultural center from Sana, so from which Catherine was like has had long-term work, so Japanese, Seijima partner. And a larger site plan of this was made by Stan Allen, so an urbanist, American urbanist. So the idea is that they tried to make designs and are developing a project so as an area between new urban developments, but that this park would be a specific park to address, to create energy and to also adapt to extreme conditions, tropical conditions, right? So again, this is the work, say, more of Philip Ron. So trying to understand, so they use this color coding. So everything in the plans that you're going to see, and even in this one, right? So the red, the blue, and the gray. So they have one system that deals in kind of technologies and configurations of landscape systems that deal with heat. Another one that deals with humidity, the tropical, and another one that deals with the pollution. And all for the sake of course, for the human, because it was centered around a central park, but then of course also the non-human. So they, as you see, this is the kind of shape of the park. So it's a system here. It's sitting between very disparate different kinds of urban tissues, and trying to understand. So doing quite a lot of modeling to inform the design. So looking at the winds, in two cases, and the influence of that wind, what it means. So kind of interpretation of a simulation by modeling to urbanism diagram of understanding, and then also understanding where we need, because of the wind, because of the position between buildings, where it's maybe too hot, or where we need cooling, where it's really we need more shade, and we need more reduction of humidity. So they come to this project again, where the pink is about heat, the blue is about cooling, and the gray is about kind of capturing, mitigating pollution. So just to know also, this site was a former airport, right? So it was an old airport in the city. That's why you have this strong linearity. So we know that some areas of the park are naturally warmer, some are naturally cooler. So that's what they used. And they measured, like with measurements to try to. So the cold winds come from the north, and the drier areas are in the southwest. And then the cleaner air is further away from the roads. That is not rocket science, that's easy to understand. So this was a competition that they won. So and these, what you're seeing are the competition drawings now. So you could say also in the world of competitions, kind of jurors that dare to go out on a limb and choose something kind of a little bit funky, and to convince the mayor that like, this is an experiment worth doing. It's also interesting. It's courageous, I think, that they first choose a jury that's courageous enough to make courageous decisions, and then that they actually went for it, and it's being built. So in that sense, it's quite nice. So, as I said, Philip Brown, he's actually Swiss, French-Swiss, and he really studies meteorology, so the weather and how the weather influences design. So for this project altogether, they had more than 10,000 square meters of solar panels, and they had 300 different technological devices that they spread around the park. So they kind of made this catalog. So about cooling and pollution and heat. So here's where we start to see some of the different maps that they have about the heat. So they, from this larger site plan and the modeling that came from it, they know cooling or heating, and then they start working, and this is where it became very interesting because, of course, Catherine Mosbach is a hardcore landscape architect. She knows all about plants, she knows the soils, blah blah blah. And Philip Grant is a kind of a boy with toys, he likes gadgets and does all this stuff. And they worked together. So this is Philip Grant, making these kind of machines and the kind of natural cooling, so a natural cooling device. On the one hand, it's natural, so trying to make it not as, again, with no fossil fuels, right? So these artificial cooling devices, they work on kind of the notion of convection and conduction. So if you remember when we saw the air differentials of temperatures, that you can use this as a way to also drive, to create energy and to move, therefore move things. So they did this with convective cooling. It's a convective cooling system. And then also where they store kind of cool air of the night, right? When the temperature drops, and then being able to kind of force it and release it as kind of basically outdoor air conditioners, to say it more simply, in the day, under these big machines. And then, of course, Catherine Mosbach, being landscape architect, okay, that's also very nice, but trees can do that too. So they combined kind of this, on the one hand, the natural systems with Catherine Mosbach and these kind of artificial in this experiment. And then the idea is that these machines would also create a new kind of park, a new kind of public space, and kind of habitation of things that came. So here you see different ways that they use these kind of simple technologies, in this case convective cooling, to work on a system. Dealing with humidity, so they also have say kind of big hair dryers, drying the air as a system. And also the one thing that the protection of humidity is literally protection from when it rains, pores. So the humidity you deal with actually drying the air when it's super humid and very uncomfortable. And then another component of it was giving more space to have these artificial shelters and trees that can protect from the rain. So this natural drying would literally blow the air dry. So they kind of have these what they call dry clouds or winds. So you force kind of air that cools. So another kind of air conditioner, but it's taking out the humidity. So they have different ways of doing this. And then with the pollution, so the pollution again here is kind of gray systems, and the pollution points were always linked to their adjacency closest to the roads. Most of this pollution is simply generated by exhaust. So they would try to find ways to kind of take particulate matters. So of course, vegetation, there's certain trees that do that very well, but then also creating these kind of depolluting devices, so where they can absorb oxides of nitrogen and other aerosols by different so they created what they call an ozone ellipse, where they're able to take out nitrogen, like it's very, very toxic, through a kind of simple system that they borrowed from the industry of cars, actually. So it's kind of using car technology to bring it into the system to reduce production. So that's where they create these other kind of systems. So in all of that, and again, the park is being grown over time. It's quite huge, as you see. And it's got on one hand this kind of system that's, say, a more traditional landscape architect, Catherine Mosbach, works with field vegetation, water systems, and then is kind of creating these machines, new machines, that are then, as the 300 of them, put in different parts of the landscape that have to do with the analysis before, that kind of artificially create clean or dehumidify or cool. So it's a kind of, again, a very new way of thinking that the technology comes in. Again, just an interesting project, I think, on this promotion of energy and urbanism. This is a very, as you see, very old project from 2001. Started, but it's a whole city called Freiburg. Freiburg is in Germany, and it's known in Europe as being one of the most progressive cities for kind of wholeheartedly, again from 2001, from a long time ago, you could say, and continuing to this day, of trying to experiment with kind of low emissions, energy production, decentralized grid, non-fossil fuel, trying to get away from steel and concrete. I mean, trying to kind of check all the boxes and say not as one system, but constantly updating itself. So it's not kind of, this is the answer and we do it here for the next 30 years, but it's kind of an open system, but all with the same goal of kind of this massive reduction and a kind of new way to make urban, and it's built. So it's a very interesting place. It's not on the kind of tourist list of things to see, but it's a very interesting city to see if you have time and are interested, because it's really innovative. So at the scale, they attract, of course, a whole bunch of architects and urbanists that are very into. I mean, it's almost, I would say, cult-like is maybe too much of a strong word, but it's really kind of gained a group of followers and people who want to be involved in this project. So with different kind of experimentation. So it's an interesting city to kind of put on the radar. To me, another very interesting experiment in terms of energy and potentials in public space. This is made by La Peña and Torres, so two, I think, really fantastic Spanish architects. And this was made in 2004 for the Forum 2004. So Barcelona is also another city that's very cleverly. So we see landscape urbanism we talked about, if you remember, as we took it, kind of how Germany is very clever at making these IBAs, the international building exhibitions. They put in massive amounts of money every 10 years. And then they have garden shows. And in the case of Barcelona as a city, Barcelona reinvents itself a lot. National exhibition, Olympics, forums, so they use these kind of big events to drive their economy, but also to experiment in urbanism. So every kind of big event, so when they have the International Expo, then when they have the Olympics, and then with this event, it's kind of radical urban experiments. So this is a piece, a small piece of a bigger experiment, which is for 2004. So this is actually where the diagonal coming through Cheryl's plant ends in the sea, right? So it's kind of used to be this gigantic, heavy-duty car. That's another project, but this is the end point. So this is where it opens to this wonderful sea. And it was kind of an area that was going to be redeveloped into being a convention center and meeting area. Like, it was going to be one of the main places for this forum, So they were creating this kind of large-scale convention center public space, but also creating a new relationship. So further to the west is kind of Barcelona, the city on the beach, but this was a kind of harbor area and a bit more rough and a bigger scale of convention centers. So this La Piña and Torres, who are really good architects, they made this public space that's on top of the convention center, and then with this massive solar array. So this new convention center, which is again the extension of the diagonal. There's also a big water treatment plant here. So this kind of large concrete canopies, okay, concrete canopy, it shouldn't be concrete. This shed, it has actually 6,500 square meters of solar panels, and that they provide energy for the convention center. So in that sense, it's quite nice. And what they did is they used this kind of massive structure, put in the right angle for the maximum sun, blah, 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 by engineering. But then they create this new public space, so like the kind of structure holding this kind of monster solar array is also part of any public space. And it's really quite, it's fascinating to visit, because also, so you can walk and then you're at a quite high elevation by the time you go up to this, as you see, and then you get this majestic view, the city behind you, in this case, in this way, the mountains, and the kind of Mediterranean at your feet, so it's quite spectacular. A kind of funny example, funny and bad example, but this is actually in Japan. So Japan, this was a former golf course. So, you know, in Japan, in many places, the golf courses were kind of prestige, and when you go to business deals are made, and a lot of prime land was, and forests and territories were destroyed for the sake of creating golf courses. Japan now, they have too many golf courses. They have a shrinking population. They have too many golf courses. So some of them are being really forested, but some of them, like this one you see, is also they're kind of covering it again. Problem, I think, is that it's not functional, but just to know that this is also happening. For me, what's a very nice project, design project. This is a project made quite some time ago by Walter Hood. Walter Hood is an amazingly good landscape architect from Los Angeles, who's a professor also at Berkeley. And he creates kind of a little bit always funky projects. He's very much, he's a guy, one of the first landscape architects in the US who was really, in the last years, fighting for a kind of social ecological justice with design as well. So this was a commission from the state of New York, and constructed for a power authority. Now, so usually not commissions that designers are getting, right? Power authority, they give a commission to create something to engineers. No? So he got this project, and it's basically in the campus of a university, University of Buffalo, to create a field of 5,000 photovoltaic panels, and that this would generate energy for 735 student apartments. So it was a kind of new student housing together with the creation of its own energy, and to reduce their emissions. So it was part of the whole project of the state of New York, and kind of a pilot project. And so what Walter did is he decided to kind of, in the story, what you see a little bit in the plan, is he decided to kind of create what he called, so like here and here and here, he created kind of rooms, so social spaces, gathering spaces, within this solar thing. So on the one hand, there's a kind of central spine that you can walk through, but then there's three of these spaces that are designed for classrooms and these kinds of things. So it's, you know, you still have the kind of massive scale of these solar panels, but again, not just a field. You could say it's covering like what we saw thought of this, so actually framing kind of another kind of public space somewhere in the shadow, of the big things, what we saw like the Banyan Forest, or what you see different relations. We know from all the solar stuff, right, that it's having quite a lot of innovation in technology. So a lot of, actually these are in China, one in California, where they're looking at kind of having these kind of floating solar farms in the water. It's also say growing. To me, this is a very, very interesting example. This is made by a Japanese, it was a kind of Japanese scientist or engineer of some sort. I don't remember his exact story. But it was a Japanese engineer who retired and went to the countryside. And he had the idea that he could develop these kind of solar canopies, but that could be constructed by like two farmers, so not heavy, not big machinery, but just like light scaffolding. Two farmers could, another guy, post in, so kind of low tech, but also it develops the specificity of the panels that they're completely consistent with allowing kind of crops. So it's not, so the way they're angled, the way it's angled, they're not burning, they're not cooking with the lettuce. So it's kind of, to me it's also a very, very brilliant way of understanding how can we double use, triple use surface areas. So actually, when Bruno and I were a long time ago working on a program for the Mekong Delta, we kind of use this as we put in surrounded by fruit trees. And also, how can you use like something so simple and turn it into a new way to define space that gets more, so isn't more extractive, but is also trying to kind of use a little bit more the resources responsibly. So these are actually examples in Florida. So Florida also another place with a lot of sun. Using them here as kind of again charging and as canopy covers for parking. So combining, I think you've seen probably there's places around the world where we see this, especially airports, where they'll have large car parking and they combine it with solar things. But then we start getting these kind of really quirky things. And you'll see some more examples, like solar trees, So you have a park and you've got a palm tree, a coconut tree, trees. And then similar to what we saw, if you remember when we saw Singapore, the gardens by the bay, these kind of technological trees. So these are less technological, so they're more, and these are made by a power company, so these kind of things I think are, these are kind of done under the trees, But I think the idea that we can design them a bit better. Here it's not as dumb, not as ugly. An example again with Germans. The German Darmstadt, the city of Darmstadt, was aiming to be a digital city. And so this was part of the German Pavilion in 2015, at Expo 2015. And so they have these kind of steel constructions, and then they have these mesh nets, and these nets have it's almost like a tissue. They have little solar panels in the mesh, so you can just stretch this tissue, this textile, across these nets, the steel frames, and they have little, so they're actually solar collectors. So then the idea is that these collect the sun in the daylight, and they have a capacity each one that they, so they're also calling them solar tree, the family of solar tree, and then they hold their day energy collected, and then they function as night lights, so it's kind of seen as being a way to also, so the idea is that they would start planting these artificial trees among almost real trees, similar to what we saw in the park by Philip Park. So you start with mixing trees and trees. Of course, then when we go to wind farms, wind is another story, of course, and most wind farms are designed as kind of these monocultural vast arrays. Many are in these ridges or in the sea. But of course, the big problem and the fights that municipalities have about wind generation is that they're also, especially when ecologists get involved, they're kind of killing birds, and they're not, so the blades are quite, they're expensive to maintain, they're quite huge, and they're destructive to a kind of, to non-human. So what's also, I think, interesting is that all this technology is changing. This is it's a yet, probably by now it is, but these are windmills, but bladeless windmills. So it was developed by two young Spanish guys. So these things work really cool. So you see them, but they go very deep in the earth, right? So what happens is the wind comes and it kind of goes through vibration, and then because the vibration is being kind of exaggerated as the section goes down, it's generating energy there. So and it's doing it from wind because these things start to vibrate or because of the wind. So there are also places where there's a lot of wind, but there's no bird killing blades so it's also all changing really, really in a quite interesting way. Then we also have these are the French design. So another kind of wind trees, So on the one hand we have solar trees, and then we have wind trees. So these are wind trees developed by some French. Okay, you could say kind of ugly, I think we could do it better, but at least they had a good idea to do it. So they create all these little windmills that create, they spin around and they create cooling, and they also you can either use it as exactly cooling, like fans, outdoor fans, but also the energy from them can be stored and it can actually be energy for lighting, for this and that, So they kind of, so they're micro turbulence kind of systems, and each leaf, so they call it one of those leaf, they have a capacity of 100 watts. And the whole tree then has a certain amount of watts, and then you can store this energy and you can light a battery. So it's kind of, so this is in a school, and they have these kind of wind trees, so not just solar tree, but wind trees. And then finally we get to some other examples about this kind of hydropower. So hydropower is nothing new in the world. We've had a lot of hydropower projects. Here, there, and everywhere. The interesting thing is that there's a generation of hydropower that are being designed also as public space. So not just these kind of machines give it to the engineer. So this is one again in Germany, where we understand that this kind of, where we have differential height as we make dams and hydropower, but it can also be designed into this kind of system of collection and of public space and new kinds of ways of doing it. So I think it's again also you could say quite architectonic, but it's taking energy infrastructure, which we really saw as like the energy sector, and if you study the energy sector, then you design the energy sector. Why? We can take it on, and so we learn design and think of how to do it more collaboratively. So again, this is piece of this project. And then we come to two last, so we have hydropower, and then we have thermal. So the hydropower, of course, is super interesting, and it works with tides, tidal differential. You have it, creates energy, push, and you create energy. So very simple kind of section. So this is a kind of dike that we see. So this is a project actually in Swansea, so in Scotland, where they create a hydro power, tidal power system. So this is the town, and then this is the bay, and so that section, so this kind of dike section that has the propeller under it, that's this, right? So they create this system, and it creates an inner lagoon, artificial lagoon, right, in the outer, so that's what we see here. So the kind of base inside and the outside lagoon in the bay. And then what they do is they design this dike that's creating the kind of ocean side and the soft side, so the artificial lagoon or tidal pool. So under this, right, where these guys are walking, is this machinery of the tidal. Is this propeller stuff? Is this, right? So this that we're seeing is the design of that dike. And of course what they show is that along this line, they have a little landing, so they have little public spaces that also become parts of the extension of this otherwise super pragmatic dike by engineers. So to me it's also quite interesting experiment, and it's under construction. This project is not finished yet. It's under construction. And so the idea is that this will be the largest marine energy development in the world when it's completed. And the idea is that we'll be able to give electricity, complete electricity, for 155,000 homes. So it's completely kind of, you could say, carbon free. So it's just generated by the tidal energy. Kind of cool. And then another one that's, if you remember in this graph of the types of energy, one of the least, say, experimented one so far, but that is being looked at more and more, is geothermal. So geothermal, it's geothermal, it's the energy and the heat that we have in the belly of the earth, and if we can also bring that up, we can use it. So they do this quite a lot already and have done for centuries in places like Iceland. Iceland does it a lot. It's also a place known not only for its thermal energy, but its thermal baths, so that you have these kind of systems. But what's so interesting is about the notion of thermal energy is that the temperature, as you go through a circuit of bringing this energy through the section, it has different, you see the different temperatures of what temperature you need. So by the time we bring it to produce power, it's 150 degrees, right? It's really hot. But we can already start looking at it at kind of the level of 20 degrees, and so we can use this kind of water cycle in its different temperature levels for different kind of pieces of the urban puzzle somehow. So here we also see, well, I think in general you know how one of this works, but it's basically going to this kind of core the earth, where they then tap and they kind of have this, well, these are the kind of machines, so it's a kind of drilling actually, that then goes down and releases this incredible energy that's tapped from below, and that's what we capture and turn into used in I think an interesting way across. So it's not a kind of only electricity, but it can be used in many. And that's why I say the tradition that we have. So again, this is putting them all together, and of which ones are really have more capacity. So geothermal has a lot of capacity, but also its initial, say, costs, and even the technology is the least developed. And the costs of doing these kind of taps and knowing where to tap these geothermal pockets under the earth. So it's kind of the least, say, capacity, but it's one that's being more and more developed. And as I say, in places like Iceland, this is from, you probably know this, Blue Lagoon. So they use it a lot in their kind of aluminum. They have a big aluminum industry in Iceland, just in Reykjavik. Super interesting. Aluminum processing, massive amounts of energy, it's all geothermal. Well, it was coal, and now it's switching to geothermal. But they also have a whole tradition in Iceland and other places as well. But Iceland is very, very strong of all these geothermal pools, geothermal, or the scale also, even of small neighborhoods, you can have these. So this is more, say, designation, tourist place. But even in the scale of like a neighborhood where you go every night to meet your friends and have a drink in the hot waters, we call Iceland. You go in these hot waters and I know I spent some time also in Vietnam, in the north of Vietnam, where they also this is very some traditional villages. This is the social space is the thermal waters. So I think it's also it's really interesting to know this, and we start having different designs that start using this as part of a whole new kind of almost driver for a new, I wouldn't say public space because this is a fancy word, but a new kind of architectonic relationship to different systems of energy. And I end this with this. This is it's a kind of it's from a book. It's a design research project called The Petropolis of Tomorrow, like Petropolis of Tomorrow. And it's looking at the ways we can begin to transform across the scale of the territorial scale of how. So it's a very interesting website to look at the Petropolis of Tomorrow. I can actually send you guys the website. So they try to work on many different levels. So diagrammatically to making pilot projects for understanding how this transition that we talk about can start to. Okay, so I'm sorry it's a little bit long. It was two things together, but we take a small break and then we come back and we